Hello friends, good evening and welcome to my YouTube channel with my name Yugal Pachori. As you all know that I do post related to different content, and recently we are continuing the series of electronic devices and circuit, and this is my second video for the electronic devices and circuit. Electronic devices and circuits, its topic related to the basic electronics, fundamental electronics, or the applied electronics. So let's continue our discussion and let me share my screen with you. This is my second video and you can find the first video in the playlist section because I have made the playlist for particular that thing. Now, we were discussing about the types of semiconductor. So basically there are two types of semiconductor. One is intrinsic and other is extrinsic. I already told you in the previous part of the video that when the semiconductor is in the pure form, it is called intrinsic semiconductor, and when the semiconductor is in impure form, it is called extrinsic. Impure means when it is doped with some external impurities. Now, why the doping is done? Doping is done to enhance the impurity, to enhance the properties of the semiconductor material. And basis on the impurities, there are two types of material, that is N-type and P-type, which is written in this blue colored heading. Now, understood? I First is intrinsic, then is extrinsic. Extrinsic further divided in two types, N-type and P-type. Now, let me read the statement for you. This particular statement, let me bring the pointer for you. A semiconductor material that has been subjected to the doping is called an extrinsic semiconductor. You can easily get the particular point from over here, and I have highlighted this point as well. So you can reread it. Now, if the pentavalent impurities are added to the semiconductor material, it becomes N-type. You can see over here, and it is over here, it is written pentavalent impurities. Now, what are the pentavalent impurities? These are those impurities which are having the five valence electron in their outer shell, such as now the pentavalent examples of the pentavalent impurities are phosphorus, arsenic, antimony, and bismuth also. So when you add the pentavalent impurity to the semiconductor, which is in pure form, initially intrinsic, then you add the pentavalent impurity, then it becomes intrinsic, and which intrinsic? It becomes N-type. Now, what are the majority charge carriers in the N-type semiconductor? This I will tell you with this particular example. And with this particular diagram, you will understand what are the majority charge carriers in the semiconductor extrinsic when the pentavalent impurities is added. Now look at this particular, let me change the pointer. Look at this particular, this is Sp. Sp means antimony. Now antimony has five valence electron. 1, 2, 3, 4, 5. Out of these 5, 4 forms the covalent bond with the silicon, this silicon, this silicon, this silicon, and this silicon. And the 5th electron is remaining. This contributes to the majority charge carriers of the N-type semiconductor, which is the electron. And it has a tendency to donate the electron. That's why it is called donor ion. And the charge on this is positive. We will continue this discussion in the coming thing. Like it will donate, this is electron, the charge over the electron is negative. However, the ion, it will have a tendency to donate the electron. Electron is donating, so the charge is reducing from negative to positive. That's why it is called donor ion, and donor ion has the positive charge. I will clarify in the further discussion. It will be just try to understand what I'm trying to say. So this is the diagram of the pentavalent impurity when it is added to the semiconductor, and you can understood that 4 valence electrons are formed with the silicon. The 5th contribute to the majority charge carriers. So in N-type, the majority charge carriers are the electrons, and the minority charge carriers in the N-type are the holes. Now understood, both these electrons contribute to the current in any semiconductor devices. So let's continue our discussion. You can see this is the valence band, this is conduction band. When the electron jumps from valence band to the conduction band, the conduction happened. And look at this donor energy level. The energy level shifts upward because there are more number of electrons. That's why it is shifting upwards. And this concept I will try to understand in the further diagrams. Now coming to the p-type semiconductor. Friends and all my followers, and I have been teacher also. You can, so I can address you as my students as well. Those who are watching this particular video, see, when you add trivalent impurity to the semiconductor, it forms p-type semiconductor. Now, what are the examples of the trivalent? Boron, aluminum, gallium, indium. These are the examples of the trivalent impurity. Now, when the trivalent impurity is added, then it becomes p-type. And the majority charge carriers are the holes, and the minority charge carriers are the electrons. This I will tell you with this particular diagram. So, understood, this is boron, this is silicon, 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 silicon. So, the boron is a trivalent impurity. It means it has three electrons in the outer shell. It will have three electrons in the outer shell. However, the three electrons forms the covalent bonding with the three silicon. But what about the fourth silicon? There is a vacancy of electron. This vacancy of electron or the void of electron is known as the hole. And it is having vacancy of electrons. So the charge of the hole is considered to be positive because you are missing the negative charge. That's why the charge is having positive because the negative charge is not there. That's why it is called positive charge. However, there is nothing like hole, but the vacancy of electron is known as the hole. So understood electron versus hole concept. You can understood silicon, silicon, and this how. And so understood the p-type have the majority as the holes and minority as the electrons. Now the one of the important this majority and minority charge carrier, this concept I told you in p-type the majority are the, now just look at this particular diagram. This is n-type and this is p-type. You can see this is in blue color and this is in gray color. This blue color, like suppose it has electrons and I told you it has donor ion and the charge of the donor ion will be positive because it has a tendency to donate the electrons. So this minus sign is the electron and this plus sign is the donor ion. So the electrons are the majority charge carriers and this holes is the minority charge carriers. Whereas in this p-type you understood like this is holes are the majority charge carriers and this is electron minority carriers, and this has a tendency to accept the electron. That's why it is called acceptor ion, and the charge on this it is negative. Why? Because they have a tendency to accept the electron. That's why the charge is negative. Now please try to understand what will happen with this p-type and n-type. Either we going to diffuse them together or we going to join them together to form a new device that I will tell you. See, we do not join P or N. Like this is P and this is N. We will not join. What we will do, we will take a single crystal of the silicon, divide it in two parts. Half part is doped with pentavalent purity, so it will become we will dope with trivalent impurity, so it will become p-type, and the half part is doped with the pentavalent impurity, so it will become n-type. Then there will be a formation of a device that is known as the semiconductor. That is known as the semiconductor. Now, what is a semiconductor? It is a device that is formed with the p-n junction. When the two material come in contact with each other, that is p-type or n-type, they are diffused such that they form a device that is known as a diode. A diode is a device which has two terminal. One is p-type and other is the n-type. And diode works in the three mode. One is no bias. When there is no voltage is applied to the diode, it is called no bias. And other mode of operation of the diode is, now let's understood what do you mean by the no bias. This is the no bias condition. See, it is this plus sign and this minus sign. It is not connected with any battery, and this is the this is the p-type and this is n-type. And you can see the electrons from the p-type and the holes from the p side and electrons from the n side diffuse together and they form the electron hole recombination. And this acceptor ion and the donor ion, they form depletion region and the potential barrier is created. How it is created? The holes from this side move towards the n-type, electrons from this side move towards the p-type. They recombine but the acceptor and donor ion, they do not recombine and they form the depletion region. Hence, the potential barrier is created. You can understood from this particular diagram. Now what happens? Look at the symbol of the diode. This is P type, this is N type. This is arrow denotes for P and this plate denotes for N. So this is the symbol of the P type. And diode works as a switch. How? I will tell you in the further discussion. Now I told you that there are three modes of operation of a diode. One is the no bias mode and other is the forward bias and the third one is a reverse bias. Now let us discuss what is the reverse bias. Reverse bias is a condition when we apply negative voltage to the diode. And what do you understand by the negative voltage? Negative voltage means the polarity of the battery is opposite. The P is connected to the negative and the N is connected to the positive. And the depletion region get increased because the holes and electrons are pulled. That's why the width of the depletion region get increased and there is no flow of current. And the diode act as an open circuit in reverse bias condition. Reverse bias means when a negative voltage is applied, the diode act as an open switch. So you got the one condition that diode is working as an open switch. Open switch means off condition. There is no flow of current. However, in the forward bias condition, now what is a forward bias condition? When the voltage applied is positive, when the voltage applied is positive, then it is called the forward bias condition. And in the forward bias condition, the holes and the electron are pushed towards each other and the width of the depletion region is increased. You can compare this one with this diagram. Here the width is high and here the width is less. And in forward bias condition, there is flow of charge carriers from P to N and N to P, which constitutes the current of the both the types of charge carriers, that is electrons and holes. When the electrons are moving from negative to positive, it gives the direction of current from positive to negative. When the holes are moving from positive to negative, they gives the direction of current from positive to negative. This is the basic concept. All those students who are students of electronics and they have done basic physics understand this particular concept. Now this symbol I have already told you. So let me summarize. The diode works in three mode: forward bias, reverse bias, and no bias condition. In forward bias, it acts as a short circuit or as a closed switch. And in reverse bias, it acts as an open circuit or the off switch. So these are the things. And this is the important diode equation. The forward current is equivalent to the reverse leakage current exponential VD over eta VT minus 1. This is the diode current equation. Whereas the IS is the reverse saturation current. VD is the forward applies voltage. Eta is the ideality factor, which is 1 or 2 for the silicon or germanium. And VT is equal to volt equivalent of temperature, which is equals to K into T over Q. K is Boltzmann constant, T is temperature in Kelvin, and Q is the charge of electron. And what is the value of the Boltzmann constant? You know, 1.38 into 10 to the power minus 23 joules per Kelvin. And what is the charge value? 1.6 into 10 to the power minus 19 coulomb. And how you calculate the Kelvin? You just add 273 to the degree Celsius, you get the temperature in the Kelvin. So this is the understanding. Now let me wind up this particular video and we will continue our discussion. So before stopping, let's understood this VI characteristic. This is the VI characteristic. Initially, the current is zero. As the voltage is going to increase, the current is going to increase. So this x-axis is the voltage, y-axis is the current. Initially, you see the current is zero. As soon as the voltage is increasing and it crosses certain threshold, that is the cut-in voltage, the current is increased. And you can see there is blue line and this dotted line. These are the two current which is increasing with application of the voltage. So this is the voltage current characteristic. And you can understood with this particular diagram as well. This is exponential plot. So let me stop my discussion over here. This is, and we will continue our discussion in the next video with the breakdown region. So thanks for watching and have a nice time. I hope you have enjoyed this video. And if you have any comments, suggestions, feedback, or any question, do post in the comment section. I will be happy to answer all your questions. Thanks for watching. Have a nice time.